All right, guys. I guess we get started on week 3. You know, I was wondering this morning, since we're in the middle of the zombie apocalypse, I wonder if the Youngstown raccoon zombies will come back this year. I don't know. Okay, so this integration by parts can be tricky at times, I'll be honest with you. It stems from the product rule for derivatives. So if we take the derivative of a product of two functions, we know that you take the first times the derivative of the second plus the second times the derivative of the first. So if that's the case, there has to be some way to go backwards using integration. Okay, and that's where this integration by parts comes from. So if I take this guy and I just integrate straight across, okay, so we're going to get the integral of the derivative of the product of these two functions f and g. Okay, so I'd have to integrate here as well. So I'd have the integral of f of x times the derivative of g of x plus the integral of g of x times the derivative of f of x. Okay, and then we would have to clean this up a little bit. Okay, so integrating and taking the derivative, these two operations cancel each other out. One takes you one way, one takes you straight back. Okay, so those two operations cancel off. We're just left with the product of f and g. Okay, then over here, okay, to clean this up a little bit, rather than writing d dx of g of x, I can just write that as g prime of x. Okay, so this becomes the integral of f of x times g prime of x dx. And I'll do the same thing right here. Rather than keeping it as d dx of f of x, I'll just write that as f prime of x. So we get g of x times f prime of x dx. Okay, then this integration by parts, okay, has to apply to either this guy or this guy, okay, because we're dealing with integration. Now normally, okay, we use this when we're dealing with kind of generating this from the derivatives. Okay, so I'm going to take this guy, I'm going to keep him positive. Okay, so I get the integral of f of x times g prime of x dx, okay, equals, let's see. Notice I would have to bring this guy and move him over, okay, so it becomes negative. Okay, it would be f of x times g of x minus the integral of g of x times f prime of x dx. Okay, and that acts as a formula for this integration by parts. Now this is somewhat confusing to look at, I'll be honest with you, okay, because you think what we have to be dealing with is we have to have an integral of a product of two functions, and one of those functions, g prime, has to be the derivative of another function, okay? Okay, so you figure, okay, this guy we know is obviously just f of x. Okay, this guy right here we would get from taking g prime of x and integrating it, okay, because you figure g prime of x is the derivative of g of x. So to go from g prime back to g, we would have to integrate, okay, and then obviously once we integrate g prime of x to get g of x, I have that right here, okay, and this is f prime, which would be the derivative of f, okay, so this formula is a formula that you'll see in most calculus textbooks, okay, it's not the only form of this formula for integration by parts, and I'll show you an easier one to look at, but this is how you generate this process, integration by parts, okay, so rather than using, okay, this, what we just looked at on the previous page, okay, we can use this, and this comes from this German mathematician. His name was Leibniz. Let me see, I think I remember how to spell it. Okay, it was Wilhelm Leibniz, okay, and he comes up with a different notation that's a lot cleaner. Okay, so this f of x right here, he represents that with a u. And then notice this g prime of x, which is a derivative, he lets that be dv. Okay, so your u is one function, and then rather than calling it v, he calls it dv because it's a derivative of a function. So that dv means a derivative of whatever function v is. Okay, equals u times v, so that would be your f times g. Okay, and remember this g of x comes from taking the derivative, okay, of g of x. Okay, so the dv becomes a v. Okay, going backwards. Okay, minus the integral. Okay, here's your v. Okay, your g of x, not g prime, your g of x, and then your derivative of f of x. Well, if f of x is u, then the derivative of u he represents with du. Okay, and this guy becomes a lot cleaner to look at, and so you will see a lot of textbooks, a lot of calculus textbooks, or if you're looking on the internet and stuff. Okay, they'll start here, but then they quickly get to this notation. Okay, because this notation is a lot cleaner to look at. So right now, this week, working on this integration by parts, you're going to see me using this notation all the time. I'll never go back to this. It's just too busy to look at. This is a lot easier to look at. Okay? All right, so we'll get through a couple of these problems today, and we'll see how we do on them. Okay, the two problems we look at today are really similar to one another. Okay, right here. Okay, first one. Okay, so notice I have a product of two functions. One function is x, one function is cosine of x. Okay, and so I've got to set this up. So I need, if I'm using Leibniz's notation, I need a u, which means I need a du. Okay, I need a dv, which means I need a v. Okay, so if we go back to this notation right here, and I'm going to put it at the top of the page, okay, so we can refer back to it without pulling this thing up. Okay, the integral of u dv equals u v minus the integral of v du. Okay, and I'll refer back to that on a regular basis. Okay. All right, so let's see. Okay, the u and the dv, okay, I've got to get those set first. So one of them has to be x, one of them has to be cosine of x. Okay, and they do not necessarily work interchangeable. Okay, if we let one be x and one be cosine of x and we interchange those, that doesn't mean it's going to work both ways. Okay, so a lot of times it's trial and error. Okay, so I've got one of two things I can do. Okay, I could let the u be x like this, okay, and then the dv be cosine of x dx. Okay, or I could switch and I could put the cosine up here as u and the x down here, or it would be x dx as the dv. Okay, now if I switch these two and put x down here and cosine of x up here, it's not going to work out. Okay, it works this way. I know because I did it ahead of time. Okay, so let's see. Okay, so I've got to come up with my du and my v. Okay, so going from u to du means I have to take the derivative. Okay, so if I take the derivative of u, that's the same as taking the derivative of x. If I take the derivative of x, I just get 1. So I just get 1 dx or just dx. Okay. Now, I have a derivative here. I want to go back to what the function would be before the derivative. Okay, so that means, okay, I've got to take the integral of cosine of x dx to get back to v. And when you take the integral of cosine of x dx, you get sine of x. Okay, so I have my u, my du, my v, and my dv. So I go here. Okay, so let's see. We go u times v. So it'd be x times sine of x. Minus the integral of v du. Okay, so it'd be sine of x dx. Okay, now this portion of it's done. Here we just have to integrate this guy. Okay, so I get x sine of x minus. All right, now when we integrate sine of x, we're going to get the opposite of the cosine of x. And then plus your constant of integration. And then obviously I would just simplify these two right here. X sine of x, double negative cancels each other out, so we get plus cosine of x plus your constant of integration. All right, now if you're ever worried about do I have the right answer, all we have to do is just check it. Okay, so we've integrated. Okay, so if I take my answer that results from integration and take the derivative of it, it should take me back to the original integrand. Okay, so if I want to check it, all I have to do is take the derivative of my answer. So take the derivative of this x sine of x plus cosine of x plus c. And if it takes me back to this original integrand, I'm in good shape. Okay, so let's see. I got a product here, so I got to apply the product rule. So the first times derivative of the second, so it'd be x times cosine of x plus the second times derivative of the first, so that'd be sine of x times derivative of x is just 1, plus the derivative of cosine of x is the opposite of the sine of x, plus the derivative of constant is just obviously 0. Okay, so if we look here, notice that this is sine of x, this is negative sine of x, so they cancel each other out, and the 0 obviously goes away, so I'm just left with x cosine of x, and that's my original integrand, so my answer is correct. Okay, so we're in good shape there. I know that's the first one. Some of you might be looking at that, and it looks like Chinese. It'll get easier as the week goes on. Okay. All right, so we got a guy right here, real similar to the last one. Okay, so again, okay, we're going to go back and we're going to say use our Leibniz notation. Okay, so my integral of u dv is equal to uv minus the integral of v du. Okay, so just like the last one, I need a u, I need a du, I need a dv, and I need a v. Okay, so going back up to the formula, x and sine of x are my two functions, so one has to be u and one has to be dv. Okay, it works if you put x with the u and sine of x dx with the dv. Okay, if you switch those two, it won't work out. Okay, so it matters which one's which. And again, it comes down to trial and error, and I know it works this way because I did it ahead of time. Okay, so if we're going from u to du, I'm taking the derivative, so the derivative of x is just 1, so I just get 1 dx or just dx. Okay, so if I'm starting at dv and going back to v, again, okay, I have to integrate to go back to v. So when we integrate, okay, sine of x, we get the opposite of cosine of x. Okay, so I have everything I need, so we just go ahead and jump into our formula up here. Okay, so let's see. I go uv, so I'm going to go x times the opposite of cosine of x, which gives me negative x cosine of x, minus the integral of v du. Okay, so that would be v du, so it would be the opposite of the cosine of x dx. Okay, so again, this first part of it's already done. The opposite of x, cosine of x. Notice if I pull out this -1 out front as a constant multiplier, it cancels with this guy. So we just get the integral of cosine of x dx. Okay, so the opposite of x, cosine of x, and then I integrate cosine of x, okay, which takes me to sine of x. Okay, so that would be sine of x plus c. Okay, so that would be my answer right there. And once again, if you need to check it, we just take the derivative, okay, of this answer, and it should take us back to the original integrand if we did it correctly. Okay, so, and you'll get to a point where you won't need to check. Okay, I think I'm running out of lead here, guys. Okay, here we go. All right, so I got to take the derivative of the opposite of x, cosine of x, plus sine of x, plus constant of integration. Okay, again, I've got a product here. Okay, so we take the first times the derivative of the second. So that'd be -x times the derivative of cosine, which is the opposite of the sine of x, plus the second times the derivative of the first. So that'd be cosine of x times -1, plus the derivative here would be cosine of x. Okay, and the derivative of the constant of integration obviously would be 0. All right, so we take a look at here. Well, the negatives cancel off here, so we just get x sine of x. And notice that this would be the opposite of the cosine of x, and that would cancel with that guy. Okay, so notice it takes us back to the original integrand, so our answer is correct. Okay, so we like this guy. Okay, we'll hold on to him. Okay, that'll wrap it up for today, and then we'll take up with a couple more of these problems tomorrow. Be safe out there.